Alrighty, welcome to the last section. This is going to be Pythagorean Theorem. It'll conclude chapter 10 for us. There is a section 10.6 in the book, but we're not going to cover it because it's a geometry and pre-calc topic. So this is going to do it. Let's just talk about quickly Pythagorean Theorem. This is something I think you've probably covered in pre-algebra, but we'll go through all the basic stuff just in case you haven't. The first is Pythagorean Theorem is only valid in right triangles, so you have to know what a right triangle is. This is any triangle that has a right angle or a 90-degree angle, usually denoted by drawing a little square in that corner. Okay, the hypotenuse of a right triangle is the longest side, and it's always the opposite of the right angle. So diagonally across from the right angle, this side is called the hypotenuse. It's always the longest side. Okay, the legs are the two other sides of the right triangle. They're both adjacent or next to the right angle. So you've got a right angle with two legs poking off of it, and then a hypotenuse across the other side. Okay, a Pythagorean triple is a set of any three numbers that satisfies the Pythagorean theorem, which we're going to do on the next slide. So this number, and this number. If it's an actual correct triangle that's a right angle here, then the set of those three numbers is called a Pythagorean triple. Now, there's an unlimited number of Pythagorean triples, but there's only a few that are actual whole numbers, integers, and those are worth memorizing. So we'll talk about them on the next couple of slides. Alright, so what is this Pythagorean theorem and how does it relate to these legs and hypotenuse? The idea is if you know any two of the three sides, and you know you're dealing with a right triangle, then you can use this Pythagorean theorem to find the third side. So A and B are the two legs, always, and C is the hypotenuse, the longer side. So the Pythagorean theorem says the length of leg 1 squared plus the length of leg 2 squared equals the total hypotenuse squared. And there's a lot of different ways that you can prove this using tricks of geometry combined with algebra. And we might do that in class on the board, but for now, for the sake of this video, we're just going to accept that this is true. And so if you know both legs, you can find the hypotenuse. If you know either of the legs and the hypotenuse, you can work backwards to find the other leg. And again, this only works in right triangles. Okay, so let's take a look at some problem solving tips, and then we'll do the examples. The first is that there are some Pythagorean triples. Remember, this is any set of three numbers that satisfies the Pythagorean theorem that you really should memorize. The first one is 3, 4, 5, because 3 squared is 9, 4 squared is 16, and 5 squared is 25, and 9 plus 16 is 25. So 3, 4, 5 is the most common Pythagorean triple. It shows up all the time on standardized tests, on the SAT, even on tests that I make, because if I want to use nice whole numbers, I'm constrained. There's only a couple of options that work. Another Pythagorean triple that's very common is 5, 12, 13, because 5 squared is 25, 12 squared is 144, and 13 squared is 169, and if you add 25 plus 144, you get 169. So these two are the most common Pythagorean triples. They show up all the time. But any basic multiple, so if I double this side and I double this side, okay, then 3 becomes 6, 4 becomes 8, 5 becomes 10. Likewise, if I double all these numbers, 5 becomes 10, 12 becomes 24, 13 becomes 26. So this is the same, this is another Pythagorean triple that works. That's a multiple of this one. Let me give you an example. 9, 12, 15 is another one that works. Or 30, if I times that by 3, right? Then 24 times 3 could be 72. And then 26 times 3 could be 78. So these crazy multiples, even if they get to be really large numbers, are guaranteed to work if they're multiples of this space here. Okay? Check your answer with common sense. Anytime you're doing the Pythagorean theorem, you know that the hypotenuse has to be longer than both of the legs. If you make a subtraction error or an addition error and you get a hypotenuse that's shorter than one of the legs, or a leg that's longer than the hypotenuse, it's extremely obvious that you need to go back and do your work. So just make sure you don't do anything silly and check your answers for common sense. And then lastly, the distance between 2 points on a coordinate plane can be found by drawing a triangle. So if I have 2 points, say I've got this point, and I want to know how far apart they are, so this dotted line here, what I can do is I can make a right triangle like this, and then this side is going to be the change in y coordinates, y2 minus y1, and then this is going to be my change in x, this length. So you can use the x coordinates to figure out how long it is, you can use the y-coordinates to figure out how tall it is. And once you know these two sides, then you can just use the Pythagorean theorem to find the hypotenuse, which would be the distance. So the Pythagorean theorem allows you to find the distance between 2 points on the coordinate plane. Alright, let's do some examples. These are just straight up plug and chug. It says if necessary round to the nearest hundredth. You can do that, or you can simplify using the way that we learned in chapter 10 to simplify radicals. So a squared plus b squared equals c squared. So we just type it in. The first one is 72 leg plus 21 squared equals c squared. When you're typing this in your calculator, obviously you have to follow PEMDAS. So 72 squared plus 21 squared equals, so this is equaling 5625, which just has that look of a perfect square, yeah? So now we're going to take the square root of both sides, type that in your calculator, and it is indeed a perfect square. It is a 75. Okay, so 21, 72, 75 is a Pythagorean triple because it worked out perfectly. Okay, let's try this one here. 34 squared is our hypotenuse equals 16 squared, that's one leg, plus the unknown b squared over here. So here I'm going to do 34 squared. I'm going to subtract 16 squared from both sides. See what I get. So 34 squared minus 16 squared equals, oh look, I got 900, which I know is a perfect square. The square root of 900 is 30. That's pretty easy. You don't even need a calculator. Okay, and 16, 30, 34. Alright, these two I'll skip for now. Exactly the same thing, a squared plus b squared equals c squared. So now it says determine whether each set of measures can be the sides of a right triangle. Okay, then determine whether they form a Pythagorean triple. Well, if they can be the sides of a right triangle, then they must be a Pythagorean triple. So, wait. Determine whether each set of measures can be the sides of a right triangle. Well, let's test. 7 squared, 24 squared, 25 squared. So, is 7 squared plus 24 squared equal to 25 squared? Let's type it in our calculator. 7 squared plus 24 squared equals, so on this side I get 625, and 25 squared, if you type that in, you get 625. So here the answer is yes. Okay, let's try another one here. 15, 36, 39. 15 squared plus 36 squared equals 39 squared. And sometimes you put a little question mark above the equal sign if you're testing it, right? So 15 squared, type that in, plus 36 squared, type that in, hit equals, we get 1521 equals, now type in 39 squared, and we get 1521. So again, it worked, and we say yes. Okay, you can check these as well. To be a Pythagorean triple, you need to be whole numbers, not radicals or fractions or decimals. And so we can check this one here real quick. A squared plus b squared. So 5 squared plus 7 squared equals the square root of 74 quantity squared. So this is definitely 25 plus 49, right? Which is 74. And the square root and the squared cancel out, so we get 74 here. So this one here, it does satisfy the Pythagorean theorem, and therefore it is a right triangle. Okay, so these are the sides of a right triangle. We could draw a right triangle with the right angle here, a side length of 5, 7, and square root of 74. However, 5, 7, root 74 is not a Pythagorean triple because this has a radical in it. So this is the idea here. To be a right triangle, they have to satisfy Pythagorean theorem, but to be a Pythagorean triple, they have to be whole numbers. And one last thing to remember about all triangles is when you add up the two smaller sides, they always have to be longer than the longest side, otherwise it wouldn't be a triangle. So that's it for this section. Get lots of practice with Pythagorean theorem. And notice, actually, let me go to one more slide here and show you. It might be nice to practice some of these where you can actually have variables. Okay, so maybe this side is x plus 1, and this side is x plus 3, and you want to find out how long is this side. So you could do a squared is x plus 1 squared plus b squared is x plus 3 squared equals, and we'll call this c squared, and then you could simplify. So I'm not going to do it here. I don't think there's something like this in the book because I didn't see them in the examples, but this might be a level 3 test question where you're combining different things that you've learned how to do in a new way. So just be aware that even though this is triangles and the side lengths make sense to be numbers, we can throw in some algebra on top of this layer of geometry. Alrighty, I'll see you in class.